Your attic may be hotter than you think. On a summer afternoon, while the thermostat inside your home says 74 degrees Fahrenheit, the space above your ceiling can climb past 130 or even 150 degrees Fahrenheit. And once that heat gets trapped, your air conditioner is no longer just cooling your rooms. It is fighting an oven sitting directly above your head. That heat does not stay politely in the attic. It radiates through the ceiling. It warms the ductwork. It keeps upstairs bedrooms hot long after sunset. It forces your air conditioner to run longer, and every extra hour of runtime turns into money leaving your pocket. And yet, for decades, there was a simple device sitting on rooftops all over America and Australia that helped solve this problem without electricity, without a motor, without electronics, and without a monthly bill. You have probably seen one before. A small, spinning metal dome on top of a roof, turning quietly in the wind. It is called a turbine ventilator, though most people know it by a simpler name: a whirlybird. And the strange part is this: these devices were once everywhere. Warehouses had them, barns had them, factories had them, older homes had them. But today, in many modern housing developments, you can walk street after street without seeing a single one. So what happened? Did they stop working? Or did modern construction quietly move away from one of the simplest cooling systems ever built? To understand why the whirlybird mattered, you first have to understand what attic ventilation is supposed to do. An attic is not meant to be a sealed box of hot air. In a well-designed home, it is a buffer between the sun and the living space below. The roof takes the heat, the attic absorbs part of that heat, and ventilation gives that heat a way to escape before it pushes down into the rooms beneath it. But when attic air has nowhere to go, the entire system fails. The roof heats up. The wood deck absorbs that heat. The attic air gets hotter and hotter. Then, as the day turns into evening, that stored heat continues radiating downward, which is why some homes feel worse at night than they did in the afternoon. The whirlybird was designed to break that cycle. It sits near the high point of the roof, where the hottest attic air naturally collects. As wind passes across the curved vanes, the turbine spins, helping pull hot air up and out of the attic. At the same time, cooler outside air is drawn in through lower intake vents, usually soffit vents near the eaves. That movement matters, because hot air does not need to be refrigerated if you can remove it before it becomes trapped. The principle is simple. Hot air rises. Wind creates suction across the spinning vent, and the moving turbine helps exhaust the hottest air from the highest part of the roof space. This is why old barns used cupolas. It is why factories used roof ventilators. It is why industrial buildings were covered in spinning vents long before modern HVAC became normal. They were not decorative. They were functional. A whirlybird takes one of the oldest building principles in the world and adds a mechanical advantage without needing power. The wind does the turning. The rising heat does the lifting. The attic gets a path to breathe. And when installed properly, the results can be significant. A standard turbine vent can move hundreds of cubic feet of air per minute under the right wind conditions. In hot climates, that can reduce peak attic temperatures, lower the cooling load on the home, and help protect shingles and roof decking from excessive heat. But this is where many videos oversell the story. A single whirlybird is not magic. If the attic has poor intake, if the soffits are blocked, if the unit is undersized, or if the roof already has a different exhaust system fighting against it, the result can be disappointing. That is one reason people began losing faith in them. A whirlybird only works as part of a complete airflow path. Air must enter low and exit high. If the lower intake vents are clogged with insulation, dust, paint, bird nests, or poor construction, then the turbine cannot pull enough replacement air. It may spin beautifully on the roof while doing very little below it. And that is the mistake many homeowners never see. They look at the spinning vent and assume the attic is ventilating, but the real question is not whether the turbine is moving. The real question is whether air is moving through the attic. This is also where modern ridge vents began replacing turbines. A ridge vent runs along the highest point of the roof and allows hot air to escape evenly across the full roof line. It has no moving parts, no bearings, no squeaking, and almost no visual impact from the street. For builders, it is cleaner. For roofing crews, it is easier to install during construction. For homeowners associations, it looks better. And appearance became part of the problem. Whirlybirds are visible. They move. They stand out. In modern neighborhoods built around clean roof lines and strict curb appeal, many homeowners and developers decided they looked old-fashioned. So even when they worked, they began to disappear. Then came the maintenance issue. The spinning head that makes a turbine useful is also its weakness. Over time, cheap units can wear out. Bearings can dry, corrode, or collect dust. A poorly made whirlybird can start squeaking or grinding, and that sound can travel through the roof structure into the rooms below. Once enough people experienced noisy, low-quality units, the reputation of the whole system suffered. But that does not mean the idea failed. It means bad versions of the idea failed. A good turbine ventilator, installed correctly, with proper intake and enough units for the attic size, can still be one of the most affordable passive cooling upgrades for the right home. And that phrase matters, for the right home. In a hot, windy climate, especially in older homes with vented attics, whirlybirds can make sense. They can reduce trapped attic heat, support roof ventilation, and lower the workload on air conditioning during peak summer heat. But in a cold climate, the story changes. Moist indoor air leaking into the attic can condense in winter. If ventilation is poorly balanced, that moisture can become mold or cause roof deck damage. And in very modern airtight homes with carefully engineered mechanical ventilation, adding random passive exhaust can interfere with pressure balance. So the answer is not that every house needs a whirlybird. The answer is that we stopped asking the right question. Instead of asking, "What machine do I need to cool this house?" older builders asked, "Where does the hot air go?" That is the question many homes are still failing. Because if your attic has no clean intake, no high exhaust, and no steady airflow path, it becomes a heat battery. It stores heat all day and releases it into your home all night. Then your air conditioner gets blamed for a problem the roof created. The first thing to check is simple. Go into your attic on a cool morning, not during the afternoon when temperatures can be dangerous. Bring a flashlight. Look at the soffit areas near the edges. Look at the gable vents, ridge vent, or roof vents. Look for daylight. Look for blocked screens. Look for insulation pushed into airflow paths. If your attic cannot breathe, the cooling system below it is already at a disadvantage. And if you already have a whirlybird, check whether it actually spins freely. It should turn smoothly in light wind. It should not wobble. It should not squeak. It should not be surrounded by blocked intake vents. And it should not be combined with ridge vents in a way that causes one vent system to pull air from the other instead of from the soffits. That problem is called short-circuiting. It happens when exhaust vents compete with each other. Instead of pulling cooler air from the lower intake vents, one exhaust vent may pull air from another exhaust vent nearby, which weakens the entire system and can even draw rain or snow where it does not belong. This is one reason roofing professionals often recommend choosing one exhaust strategy and doing it properly, rather than mixing everything together. A whirlybird can work, a ridge vent can work, a gable vent system can work, but a confused roof with several competing exhaust paths may work worse than any one of them alone. That is the real lesson. Natural cooling systems do not fail because physics stopped working. They fail when the system is misunderstood, undersized, poorly installed, or replaced with a cleaner-looking option that ignores how the house actually breathes. And this is where the old spinning vent becomes more than just a piece of hardware. It represents a different way of thinking about a house. Not as a sealed box that must be forced into comfort by machines, but as a structure that can move heat, moisture, and air naturally when the path is designed correctly. That is why these devices stayed on barns, workshops, warehouses, and older roofs for so long. They were cheap. They were simple. They used wind instead of electricity. And when maintained, they could last for decades. So why did we stop using them? Because modern construction favored invisible solutions. Ridge vents looked cleaner. Mechanical systems gave more predictable numbers. Homeowners associations disliked visible rooftop hardware. Cheap turbine models damaged the reputation of good ones. And most importantly, once AIR conditioning became the default answer, passive ventilation stopped being treated as a design priority. But the heat never stopped rising. The attic never stopped trapping it. And the roof never stopped needing a way to breathe. So maybe the question is not whether whirlybirds are outdated. Maybe the question is whether we became too quick to dismiss simple systems just because they did not look modern. Because a spinning metal vent on a roof may not be impressive. It may not have an app. It may not connect to Wi-Fi. It may not come with a subscription, a service plan, or a smart controller. But on the right house, in the right climate, installed with the right intake, it can still do exactly what it was built to do. Pull heat out before you pay to cool it. And that might be the reason this old technology is worth looking at again.